Now, let us talk about the OSI model. Now, the OSI model is nothing more than a model. I mean, that's really the best way to explain it. So, if I wanted to build an airplane, what would I do? I would build this interesting airplane model to give me an idea what the airplane might look like. If I was going to design something, yeah, I'm going to have blueprints and stuff like that. But I would have some type of model to have some type of idea what it would look like. This is similar to that. Not 100%, but it's similar. If I wanted to have this method, this way of communicating between one device and another, I would have some type of model to use to make sure that communication happened between one PC and another. So although, again, this is something that we are not going to be changing, we're not going to be going in there and making changes to these layers, per se. Some of the configurations that we do will make changes to the actual layers as the data is being sent out. But this model is based on communication between one PC and another. We call this the OSI model. And as you can see, it has 7 layers. The layers will start to make sense here by the time we're finished. Starting at the top, we have application, presentation, session, transport, network, data link, physical. By the time you're done with your CCNA training, you should know all these by heart as far as the names of these layers. As far as understanding what each one of them does, you should have a okay understanding of application, presentation, and session. You should have an okay understanding of transport. A little bit more than okay understanding, I should say. And network and data link, you should have a pretty good understanding. Now, when I mean understanding, you're going to understand how these layers are built. And the OSI model is used as a means of educating us on how this traffic is moving from one data to another. Now, if someone wanted to build protocols at a particular, deep down and wanted to build protocols from scratch, manipulate protocols, create a device that needed to run protocols, they would use a model like this. Each one of these models go pretty deep. But as a CCNA, you're not going to be going that deep, but you're going to be going deep enough where it's not something you're just going to remember off the top of your head. You will have to deal with some headaches as far as learning this information. So let's talk about what each one of these layers do. Now remember, we are talking about communication. So when we're sending traffic from PC 1 to 2, depending on what type of data we're going to be grabbing, we might not use all the layers. But let's say we're actually going to use all the layers for this particular application, or for this particular transmission. And PC1 is going to communicate with PC2, and what he wants to get is some data, and we'll say web page data. So you go out and you say, hey, I'm going to go to www.yahoo.com. Now, this information is going to be sent over to PC, and PC2 says, let me give you that information. So what I'm going to do is I'm going to send you this information, and as I'm sending it to you, I'm going to build my layers one by one before I send this traffic out. So, the application layer. The application layer is really where the user sits. So if I was sitting on a web browser here, this is where the user will interact with the application. Now, when you start reading about each one of these layers, it's a lot to them. I'm just giving you the basics. So a user sits down here, uses a particular application, and that application will be communicating with another device. So in this application, we'll use Firefox. Web browser. We go into Firefox, we type in yahoo.com. We send that information over here. And PC2 is going to be using some information that he sent back. He's going to have a presentation layer in that data. Now, this presentation layer pretty much does what it says. It's how the data needs to be presented to the user. Have you ever pulled up a web page and the data was like all in this format? You know, normally, you know, this piece of data should be over here on the page in this box, and this piece of data should be up here at the header somewhere. You know, and this one should be a picture sitting over here. You know, but somehow the presentation information didn't get sent over. Somehow the presentation layer got corrupted, got messed up somewhere. So we end up getting this type of format. That's all on the left-hand side, all up and down, and it doesn't make any sense. It's happened to me many times. This is the presentation layer not being sent over to where it needs to get to. Somehow the presentation layer did not either present the information correctly, or it just wasn't sent over, so that other PC that's receiving that information didn't know how to present the data to the user. Does that make sense? So this presentation layer, its job is to make sure that the data is presented correctly. Now, you can look at the fact that I'm a user and I'm going to use this application. The application is going to send information to the presentation layer saying, look, this is how I want this to be presented before it's sent out. And then the presentation layer is going to actually look towards the session to create a session between two PCs. And we're going to talk about that in a minute. Now, I'm not saying the presentation is heavily relied on the session, but each one of these layers works with each other. They're relied on each other to do their job so their job can be done. Read about the OSI model. This is a reading topic. There's lots of topics that's a reading topic. Session. A session is the means of creating communication from one PC from another. Remember we talked about the walkie-talkies and we talked about the channel? Well, imagine these logical channels, these logical pathways, where the data itself will travel down this logical path. This session is really important because when PC1 tries to communicate with PC2, there needs to be some sense of communication. PC1 is going to send information over to PC2 and say, look, I'm trying to communicate with you. PC2 says, okay, I get that. Let's go ahead and let's start a communication. And it's the logical flow, this logical channel, so to speak, between these two PCs will be formed. And then we'll start sending data between PC1 and PC2 using these logical channels, so to speak. But these logical channels are called sessions. Now, the job of the session layer, its job is to maintain that session. But in order to maintain it, it has to what? It has to start the session. Its also job, after starting the session and maintaining it, its job is also to stop the session or tear it down when the communication between the two PCs is done. That's the job of the session layer of the OSI model. They're just logical connections between PC 1 and 2. Now, the transport layer is pretty interesting. The job of the transport layer, its job is to communicate using traffic that is called UDP, TCP. Its job is to segment the data. It uses sequence numbers to do this. And it also has an interesting thing to use between communication, which is called port numbers. Now, each one of these things has its own lesson to teach. This means if the traffic is going to not be guaranteed. It means I'm just going to send the traffic down the wire, and I don't really care if it gets there or not. It's best effort. I mean, I want it to get there, but I'm not going to make sure it does get there. TCP is a method of being guaranteeing traffic and making sure that my traffic is being being delivered. And in order for me to get that guarantee, guess what? I'm going to use sequence numbers to make sure that I'm getting the proper data back and make sure that my data is being sent. Let's see how that works real quick. If I'm seeing a piece of data over to PC1, now remember, sequence numbers and TCP TCP uses sequence numbers to make sure we have guaranteed communication, which means if you're using TCP, you are expecting reliable transmission between both of these devices. PC1 sends a piece of data over. Here's my data. Comes over here to PC2. Attached to this data, we'll have a sequence number. Let's say a sequence number of 1. PC2 will come back and say, look, I have this data. I got it. He's going to send what is called an acknowledgement. And with that acknowledgement, he's going to send a sequence number of 2. That sequence number of 2 means to PC that means to PC1. When PC1 gets this acknowledgement with the sequence number of 2, he knows PC2 is expecting sequence number of 2. If PC2 sends this acknowledgement back with a sequence number of 1, it's telling PC that he's expecting a sequence number of 1. And PC1 knows that, well, if you're expecting 1 and I already sent 1, I need to resend 1 because you're not getting it. So I'll go ahead and resend that. And these sequence numbers are what's used to guarantee this traffic back and forth. That's just the basics. We'll get a little bit more detailed into it later on. Port numbers. Think of port numbers as a means of listening on a particular gateway. Now, I say gateway, I'm talking about a hyperspace gateway, not a gateway in networking. Think of them as, well, you can think of them as tunnels, but then we have tunnel interfaces, so that might confuse you. Think of you actually going through a wormhole in space. If this PC one is sitting here, and I'm trying to send data over to PC2, and I want to send it out port number 23, I'm going to send this data through this nice little wormhole, bending space and time itself. Yeah, right. Going down port 23 over to this PC. Now, that's one way of looking at it. But then some people get confused with that as well, because they think that this 23 is automatically opened and so on and so on. So let's think of it as another way. I like explaining it that way because a lot of people read it as a wormhole and it get kind of confused. I like to think of them also as this wall of doors sitting on the PC. And we got lots of doors, okay? And here's our door handle for each one of these doors. Imagine that these doors have numbers on them. Now, PC2 is going to be listening at each one of these doors. He's going to have his ear up to them. PC2 gets to find what port numbers or what doors he's allowed to listen on. So PC2 will say, I'm going to listen on door 23, on door 15, and on door 33. Okay. So these are the only doors that I'm going to be listening on, and that's it. So if PC1 sends information over to PC2, and he says, I'm going to send this information to port 25, and PC2 is not listening on the port 25, he'll never be able to open one of these doors. He's not going to open the door for that traffic to come through. And in fact, PC is going to say, I'm not listening on 25. See ya. And they'll drop the data. So these so-called port numbers, or these doors, PC2 needs to be listening on that port number in order to allow that traffic to go in. Now, if I communicate on port 23, well, that's beautiful. That's fantastic. PC2 will actually allow that traffic to come in, open this door, because he's listening on 23, and that traffic will be allowed to come in. This is the transport's job, to make sure of this transformation. So let's look at it like this. I'm going to have my application, and I'm going to build my application. In the application, I'm going to say, I want this application to be port number 1111. 1111. So what's going to happen is whenever this PC, we'll say PC1, is using this application, and that PC starts building these layers, the presentation layer, the session layer. The session layer, remember, the session layer actually goes out and tries to create this session. Once the session is created, now we're going to get to the transport layer. And the transport layer is going to define whether it's going to be UDP or TCP. If it's UDP, who cares? It's just going to send it out with the port number and be done with it. If it's TCP, we're going to set up a TCP session first to make sure we have this guaranteed traffic communication going. And once we get that TCP session set up, every time I go through and communicate to that other PC, it's going to be with port 1111, that door. So this is nice because if I have a PC sitting here, PC1, going into the switch, PC2, PC3, and I have a server sitting here. This server could be listening on port 1111, and these PCs are not. So that's nice to know because I know if my traffic accidentally gets to PC2 or PC3, who cares? They're not listening on port 1111, so who cares? 2 and 3 will drop it, and as long as the server gets it, he'll allow the traffic to go through. He'll read the traffic, see what it's for. whatever request that server has, he will send it back out. Now, this is pretty cool. Now, remember, this is just the basics. We're going to get a little bit more detailed later on. So if it's not making all sense to you, that's fine for right now. So the application will define whether he wants to do UDP traffic and TCP traffic. And this is why I'm talking about that the layers work with each other. Because the application will definitely tell the presentation how it needs to be presented. And the presentation will make sure that that happens. The presentation will work with the session to make sure that the session's up. And when I say they work together, really the presentation is really working with the application. Technically, it's really working with the presentation. After this part has been defined, the session will start to be created, and really the transport and the session are kind of working together. Because the session is created as this logical communication between the two, and based on the application, how it defines what type of traffic it wants to be. If it's UDP traffic, the transport layer will go ahead and build the information, send that traffic off, and rely on the session to keep that session open as long as it needs to be, so to speak. And as long as this transport layer is sending this information out, guess what? The session remains open. But if it's TCP traffic that it wants to do, it's going to create this TCP communication between the two, and we're going to use secret numbers to guarantee that our data is being delivered. Now, segmentation is important too, because segmentation allows us to take this huge piece of data, break them up in chunks, and give them identification numbers. So that way, if this data comes over to here, but he gets 3 first, then 1, then 2, then 4, he's able to take this and say, okay, this goes here, here's 1, and okay, we have 2, 2 goes here, and of course we have 3, and then we have 4. So we get to put identifiers on these. A lot of stuff going on in the transport layer. So the transport layer its job is to say, look, these are the port numbers that I'm trying to communicate on. If I'm using TCP, I'm going to use secret numbers to make sure that I'm guaranteeing traffic back and forth. This is where I'm going to be segmenting my data, splitting it up into pieces. And this is also where I'm either going to be doing UDP or TCP traffic. In a nutshell. Now the network layer. The network layer. This is an interesting layer. The network layer's job is to provide its own IP address in the information that's being sent. That would be the source IP. And its job is also to put the destination IP address in. This way, when the router gets the information way down the way, or every router that gets the information, doesn't matter how far down it is, the very first router that gets this information, guess what he's going to look at? The destination IP. And he's going to make a forwarding decision based on that destination IP. And this is what I mean by routers sit and work at layer 3. Because the router only cares about the destination IP when it's doing forwarding decisions. When it's making a forwarding decision, this destination IP is its main source of moving that traffic. So if I have a router 1 here, and he has data coming into router 1, and the destination IP is telling the router, okay, for that destination IP, I need to go this way. And I say it's telling the router, but it is telling the router what the destination IP is, but then the router uses a mechanism to find how do I get to that destination IP address? Which interface do I use to get to that destination IP address? And that's how it works. Let's repeat that. Traffic comes into router 1. Thanks to the layer 3 information that we're learning in the OSI model, it's going to have the source IP and the destination IP. When the router gets that information coming in, router 1 is going to say, okay, I'm going to look at the destination IP. Great, I have the destination IP. Which interface do I need to use to get to that destination IP address? Oh, it's this one right here. So I'm going to go ahead and forward that packet out this interface. Or forward that data out that interface. Layer 2. This is where our switches are used. Now remember, our network layer uses IP addresses. Our data link layer, or our layer 2, will actually use MAC addresses. So that means in this information, we'll have a source MAC and a destination MAC. Now the physical layer's job, its job is to take all this information, because up here is actually the data we need to actually get, right? I mean, that's really what we're looking for. We're looking for data. Yes, the application might be sitting right here, but there's lots of data I need to send. When I go to yahoo.com, I got lots of data to give to that person. Lots of it. But I need to also add this information on with that data. Now the physical takes the data and all this information, the presentation information, session, transport, network, data link, and converts these ones and zeros to electrical signal. That means we put that bad boy on the wire. We call this serialization. We're putting the data on the wire. And then these electrical currents travels down the wire. And this is pretty much the basics of the OSI model. It gets complicated because people go into real detail, and I feel that the OSI model needs to be as simple as possible starting off. So now let's take a look at how data is built from the very beginning. And let's go take a look at all this information over here that we got. After everything I just explained to you, let's see how this is built out. So the application layer, I'm going to bring this right over to here. So the application layer says what? User's data sent from the app. Okay. The user's data sent from the app. Let's think about that. When I'm going into my Firefox, what data am I putting in there? I'm putting in the URL. Isn't that what I'm putting in there? HTTP :// yahoo.com. If I'm sitting at that particular site and I type in show me the weather, that's data that I'm putting in. So you're starting to see this. This is where the user is sitting at the application. Give me data. Okay, show me food delivery. I want to find a place that delivers food. This is data that you're putting in. Now, notice this concept I say right here, or what they say. I mean, these are just things I get out of that I've learned, and I'm passing it on from other people that have taught me, which is I'm self-taught, but it's still someone's writing the books, someone's making the videos, right? So yeah, I'm being taught, just like you are now. Header information. What is a header? So a header is something that sits in front of the data. Now, some people write it this way, saying, that the data sits here and the headers are sitting here, header information, header. Some people like to write it this way, which is me. I like to write it this way, and I have my header, and then my header, and my header, okay? But when you're looking at this, if I actually was going to sniff that data, what does sniffing means? Sniff means I'm actually grabbing the raw data that's going across an interface. That's what sniffing is. And if I was going to look at that data, it will be at a bottom to top formation. So my data will be sitting here. Then my transport will be sitting here. Then my network will be sitting here. And my data link will be sitting here. Now this means, in this type of transformation, I'm only using layer 4, 3, and 2. And then the physical layer will actually send that onto the wire. But this is how you would see it if you're actually looking at a program that's called Wireshark. And Wireshark is used to actually see the data as it's leaving or coming into your interface. If you downloaded Wireshark, which is free, and look at the data on your interface, you will see all types of traffic. It would look foreign to you. You're just like, I don't understand what's going on. Hopefully, after I explain this, it will start to make a little bit more sense to you. So we have our data here. Now, I want you to think about, this is PC1. And PC1 is going to send data over to PC2. But he has to build all this information first. So he has the data that needs to be sent. And remember, a header is just something that gets put in front of the data. So the user types in this information, and he's going to put this little bit of information in front of the data. Just this little bit of information. Now, once I put this header here, that means I'm going to see this first once someone looks at it. So that means now the data is hidden. The data is hidden behind this header. Now, once this is done, I'm going to send this down to where? I'm going to send this down to the presentation layer. Now, the presentation layer is going to say, okay, I know how it needs to be presented. Let me put that information in my header, and boom, I'm going to put this little header on top in front of the data. I should say in front of the application header. Then this information gets sent down to the session layer. The session says, okay, I'm gonna build the session, get this created, get this started for you, and it's gonna put its headers on there that are needed. Then he's gonna send it down to the transport layer. Transport layer is gonna say, okay, this is the information that I need to put in there. What do you think he's gonna put in there? Source port number and destination port number. Now, the source port number could be a port number that the application is using, or it could be a random number. But either way, if he's using port numbers, he's going to have a destination port number. Doesn't mean he's going to have a source port number that he defines, but he will have a source port number, and if it's not defined, it will be random. And Windows would just choose a random one. So the source and source port numbers and the destination port numbers will sit here. And that's good to know, because whenever this traffic goes over to PC2, PC2 will look at this header information and say, oh, okay, where are you trying to, who are you trying to communicate with? Oh, you have a particular destination port that you're trying to communicate with. Let me go ahead, see if I'm listening on that port. I am. Come on in. I'll let you come on in. Then that information gets sent down to layer 3. Now it's time for layer 3 to build his header information. In that header, he's going to put the source IP and he's going to put the destination IP. This is golden. Golden information. The routers need this information. It gets handed down to layer 2. The layer 2 information will say, okay, I'm going to put the source MAC and the destination MAC. Very good information. Switches need this information when they're forwarding data on. Then all this information, this data with all these headers, gets put onto the physical. And the physical will actually take all this information, these ones and zeros, and convert them into bits. What type of bits? Wire bits. Electricity bits. However you want to say it. It converts it into electricity. That's what it does. Now, if you look at the presentation, if we go back up, you can see that it makes sure that the data is presented correctly during communication. The last thing we want to make sure is that data is getting corrupted or not being presented right as the information is going back and forth. And it tells you it deals with formatting and translation between formats. That's nice to know. If we have different types of formats. And if that transport layer is able to take one format and convert it over to another to make it more presentable, that's fantastic. Look what the session says. It establishes, maintains, and terminates, which this will be tear down or terminates, my sessions, my logical communication between the two devices. It also syncs and manages the presentation information. See how this one works with this? A rule of thumb is to say that the lower levels always work with the upper layers, and the upper layers always depend on the lower layers. You can look at it that way. But it syncs and manages the presentation information between the two hosts. Make sure that that information is understood on both ends. The transport layer. Look what this says. It splits the data, these are the segments I was talking about, into segments. It reassembles the data. Didn't I tell you that we can actually reassemble that data with the 1, 2, 3, 4 as I was doing on the other side? It establishes, maintains, and terminates the virtual flows. So I might have said that sessions were virtual connections. Yes, they are this logical connection between them. And in that logical connections, we have what's called logical flows of traffic or virtual flows. So if I have an IP address of 192.168.1.1, and I'm communicating on port 2001, and my traffic is going to 192.168.1.10 to port number 2001, this is my flow. If I solve this, whole thing will be a flow, a virtual flow. And we would have this virtual communication between these devices using an IP address and a port number. What else with the layer 4? This is where we use our TCP or UDP for communication. It does flow control, which we're going to learn about that flow control. It has errors, retransmission. Now, retransmissioning or retransmitting has to deal with the flow control. Notice in our TCP, we have segments, which is the same way we talk about up here, splitting it in segments. Sequence numbers, which is what I was telling you about the sequence numbers, to make sure that we are getting the data with the acknowledgments. And remember, PC2 will say to PC1, I'm expecting this particular data with this sequence number. And if that's not there, or if it's the wrong number, then PC1 will resubmit that data. All cool stuff, because TCP is guaranteed delivery, which means we're making sure that this data is getting from point A to point B. So we got some overhead. UDP means best delivery, man. I'm going to send it out that interface, and I hope it gets there. It's like throwing something out in space and just saying, man, I hope you get to the moon, and still using thrusters to make sure we get there. Our network layer, let's see what that says. Our network layer says it's responsible for selecting the best path to the destination. This could be kind of misleading because it's the router's job to make sure he's routing the information correctly. So if the router gets the information, he's going to look in the information that's put in the layer 3 header, in the layer 3 information. And he's going to look in his own table and say, I see the destination IP address here in the layer 3 information, in my layer 3 header. I see that information. Now let's find out what interface I need to go out of to get to that data or get it to its destination. So router 1 will use the destination information in here to make a forwarding decision. IP addresses are used here. IP addresses are layer 3. We call these packets. Anytime we're making forwarding decisions on layer 3, we call that data packets. It's just a name we use, packets. I don't know exactly how it arranged from that. I don't know the history, but we call them packets. Our layer 2, our data link layer. It controls how data is formatted for transmission. We use MAC addresses here. And instead of calling them packets, we call them frames. Okay? And then our physical is the layer that is of the physical world, which means physical just doesn't mean that we're putting data onto bits of a wire. The wire itself is considered physical. Anything we can physically touch. A router is physical because it's a device we can touch. Logical means it's something that we can't physically touch, but it is something that exists. But then you have to say, well, does it really exist because it's logical? But it exists because we interact with it. That's why. You can have the philosophical idea later on, whether it really is physical or not, or logical or not. So, things that you can physically touch, wires, equipment. Now, that's one aspect. But when we're putting the information on the wire, we're dealing with voltage, timing, maximum distance. There's only so far that this data can go. If we go back and look at our Ethernet types, we can see that 10 base T only goes 100 meters before it will start having problems. So is 100 megabits per second or 100 base T. Even 1 megabits per second over twisted pair. Still, we got the same limitation. But a gig over fiber gives us 5,000 meters, man. That's That's a big change. That's a big change. It might not be 5,000. It might be 500. So make sure you research that. I'm not a cable guy. Neither are you. So this information is nice to know, but it's not. You might get questioned this on the CCNA exam. I mean, don't get me wrong. So this is what really the OSI model is for. You can go really deep and to find out what it's for, and I mean really deep, or you can do what I did with this information and use it just as a means and a tool to find out how one PC communicates with another. And that's all I do. Okay? So if I wanted to communicate with one PC to another, let's think about this. PC 1, PC 2. PC 1 is going to send data over to PC 2. He's going to take his application data here. He's going to put his header over the data. He's going to put his presentation information here to make sure that his presentation is sent in a way that he wants PC2 to see it, and how he wants PC2 to present that data to the user. The session will be created to make sure that communication between 1 and 2 is up, maintained, and stays up until it needs to be terminated or torn down. Our transport layer will tell us what ports that we are communicating on. It'll also let us know if it's UDP traffic or TCP traffic. Remember, UDP is best delivery, TCP is guaranteed delivery. Then we get to our network layer, which is layer 3. That's going to be what? And actually, this information goes right here. The layer 3 information is going to have the source IP in there and the destination IP. Now, what is the source IP? The source IP is the PC of the one who's sending the data. So if this PC is 192.168.1.1, his source IP will be 192.168.1.1. If this PC is 192.168.1.10, and he's trying to communicate with PC2, his destination IP address will be 192.168.1.10. He's also going to go to the data link layer, and that data link layer is going to put in what? Source MAC and the destination MAC. All this information gets set onto the wire as electrical signal. That data gets sent over here, going out the network card now. This is where we're leaving the network card. The network card itself is putting this information into electrical signals and sending that electrical signal over the wire. That data comes over here, comes into our network card. And now the network card looks at it and says, okay, what's the destination MAC? He's now looking at the layer 2 information that came from PC1. And he's going to say, okay, let me open this up. He opens up the layer 2 information. He looks at the destination MAC and says, oh, well, that's my MAC address. If it wasn't his MAC address, he would drop the whole data and say, see, that's not for me, I don't care. But since it is, since the layer 2 information has a destination MAC address of me, as I'm looking at this data, that means it belongs to me. So I'm going to strip this off. And now I'm going to look at the layer 3 information. The layer 3 information is going to have the source and destination IP address. I'm going to look at the destination IP address because this is an ingress packet here. It's ingress. It's coming into me. So if it's coming into me, I need to be concerned with the destination data. I'm not sending it out. It's information coming to me. I know what the difference is. And since it's inbound on my interface, I looked at the destination layer 2. I saw that it was me. I took that off, and now I'm going to look at the layer 3 information. Now, this makes sense, right? Because when I originally get this data, I'm not going to see all of this. Only thing I'm going to see is the layer 2 information. So I'm going to open this up, remove this, and then I'm going to see the layer 3 information. Oh, well, that makes sense. Let's open this up. Let's find out who this belongs to, who this is going to. So I'm going to look at the destination IP address that was sent from PC1, and now it's sitting at my network card. Oh, the destination IP address is 192.168.1.10. Well, that's me. So if it wasn't me, at this point, I would drop it. If it was going to 192.168.1.5, guess what I would do? I would drop that data. But since it's going to 192.168.1.10, I'm going to go ahead, since it's me, I'm going to say this belongs to me. I'm going to go ahead and strip this off and now see what's underneath. So it's pretty interesting how this works, because we're not going to go any farther if any one of these steps doesn't belong to me. So now I'm going to look at the layer 4 information. I'm going to look at the destination port if it has port numbers in there. If it's got a port number of 55 and I'm not listening on 55, I drop it. I decided, nope, sorry, I'm not listening on this port. You're not getting through on that port number. So the data gets killed, it gets blocked. If that destination IP, or a destination port number is 55 and I'm listening on 55, I will allow that traffic to come in. Okay? The session is still doing its job, maintaining what it's supposed to be doing. And now this PC is going to look into this information and say, okay, this is how you want me to present it to the data? It's present the data to the user? I'm going to do that. I'm going to use this to make sure I'm presenting it to the data correctly. Looks at the application information and says, oh, okay, this is the application we need to be using. This is where the application is going to, so on and so on. Technically, the port number will define where it's going to, but I'm going to use that application information to make sure I open it up, and I'm going to make sure it's presented correctly. Then that information comes up, and now I can finally see the data that I wanted to see. And while you're looking at this, you're saying, wow, that's a lot of information. Steps, yes. And you get your website just like that. Just like that. The second you type in www.yahoo.com and hit enter, this is what's happening in the background. Now, as a network person, because this is nice to know, guess what you're going to be dealing with? Layer 2, Layer 3, and Layer 4. People like to say sometimes Layer 4, but trust me, you're going to be working at Layer 4. There are some things at Layer 4 you might not be too much into, but you're concerned with port numbers. Really. You really are. But not as much as a firewall guy. Now, firewall will spend a lot of time here on Layer 4. Allowing ports to come in, denying ports, shutting down ports, traffic that's coming in on one port, make sure it goes out on the same port, things like that. But this information up here, you're not really concerned with. There's other folks that deal with this. You're not concerned with it at all. So, us as network folks, in our world, we deal with the network layer, the data link layer, and what's the other one? Transport layer. Now, just when you thought that you knew everything about the OSI model, now we talk about the TCP model. I'm not going to go really deep into the TCP/IP model because it's still a model, guys. I mean, it's still the same thing, except the fact that the TCP/IP model is just a different type of model. It just, look at it. If we compare it to the OSI model, let's take a look at that. Look how the application is really the application of the OSI model and the presentation in the session. Look at that. So the application, the presentation, session is now just one layer in the TCP/IP model that is called the application. But this is still present. This still has to be done. The presentation still has to be done. The session still has to be done. It's just wrapped up into one. Now the TCP/IP model says, look, that's really the job of the application. So we're going to leave it at that. Okay? Now, as you look over here, you can see here's my IP layers. It says application and session. And as you can see here, this session of this IP model deals with the session and the transport. But over here, this model has a transport of the OSI model, and it deals with TCP and UDP. It has a transport model as well. And notice that this network layer over here, they call it Internet Protocol, which is IP, data link, physical, and physical. When we look over here, we kind of just have the application, the session, which deals with the session in the network, and the app in the network that deals with the network, data link, and physical. We got different type of models out there. We got some old ones and we got some newer ones. You can follow what's in the book, but the bottom line is it's not going to change how the data moves regardless. When you start understanding how the data moves from a perspective, you're not going to keep going back to the OSI model in that fashion and say, okay, let's check the OSI model. No, you're going to be paying attention to layer 3 and layer 2 in a different fashion. But the OSI model is a necessity to learn these things. So let's take a look at this one. Now, we got the OSI model still here: application, presentation, session, transport, network, data link, physical. I use the OSI model to learn this, and I've used the OSI model for teaching. But again, it's just a model. Here, you can see we have an application layer, transport layer, internet layer, and network interface layer. So different types of models. Now, TCP/IP is nothing more than a suite of protocols. A suite of protocols. What's a protocol? A set of rules. As you can see at the application, TCP will have HTTP, FTP, DNS, SNMP, SMTP. So these are applications that come with TCP/IP. You have TCP/IP installed, most likely you're going to have these programs. It's a suite of protocol. Even RIP. And yes, you have RIP on your Windows machines. You have to go in there and install it. It'll say RIP listener. And you can actually send network routes over to your PCs, which is really awesome. In our TCP suite, you can see our transport will deal with TCP and UDP. Look at our internet layer. We got some interesting things there. ICMP, IP version 4, IP version 6, ARP. And then our network layer, we have Ethernet, which what did I tell you? Ethernet is a standard, right? Set of rules on how to communicate over certain types of media and between devices. Wireless. Oh, I didn't know I can run Ethernet over wireless. Well, yeah, you are. And in that wireless, you have a thing called CCNA, where here on the physical LAN, you have CCNA, what you're going to learn what this one is, except this says collision detection, this says avoidance. And we have another layer 2 technology here, which is called frame relay. So these are just models, guys. That's all they are. They're just models. If you start to get too confused on this, just understand that you might be thinking about this too much. The most important thing to understand is really trying to memorize what each one of these does. And if you utilize the information, like the name of the layer, it should be helpful. Application, that means a user is sitting here using the application. Presentation, this means how do we want to present the data to our neighbor, to the person we're sending the data to. Session, this is creating logical sessions or logical connections between each other. Transport's going to be your biggest one. That's the one that's you're going to have some problems starting off. Eventually you'll get it. And when I mean eventually, I don't mean it's going to take you a long time. It's just, you'll learn it. And let's say 3 months down the road, you can't remember it. That's fine. You know, it's just part of it. We forget things all the time. You know, you ask me what the port number of of Telnet is. Sometimes I say 22. And the people on the phone are just like, you sure about that? I have to think Telnet. Oh, no, I'm sorry, it's 23. I know it's 23. I know DNS is 53. I know TFTP is 69. But you forget. Your brain has lapse, you know? It just forgets. The network layer, you remember this is IP addresses. Data link layer, this is MAC addresses. So when I tell you that I'm dealing with layer 2, this is layer 2 traffic. That means I am forwarding my data based on MAC addresses. Oh, this is layer 3 information. Oh, that means I'm forwarding my data using IP addresses. Now let's say that one more time. Data link layer, layer 2. That means I'm making forwarding decisions based on the MAC addresses and where they sit and how my table is built. Layer 3 means I'm using the IP addresses as my forwarding decisions based on the table that I have telling me what interface to go out of. Okay? So these two do the exact same thing. They use a table to make forwarding decisions, except layer 3 uses IP addresses, layer 2 uses MAC addresses. Can't get any simpler than that, right? So that's pretty much it with this lesson as far as chapter 2 is concerned, which is the OSI model.